When you place an angle in standard position, its terminal side can land in any of the four quadrants. Pick any point on that terminal side. Its coordinates x and y, and the distance from the origin r, define all 6 trigonometric functions. X and y might be positive or negative depending on the quadrant, but r is always positive, like your teacher's attitude on a good day. These 6 values are called pure numbers because they're all ratios, one length divided by another, so the units cancel out. That's right, no centimeters, no inches, just numbers in their purest form. And why 6 functions? Because 3 would have been too easy. But don't worry. Cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent. They're the understudies of trigonometry. You might ignore them now, but one day you'll be glad they showed up. Here's a quick way to memorize the big 2 trig functions. Sine is shy, goes with y. Cos is nex, goes with x. I am afraid I couldn't think of any more silly mnemonics for the rest of them. Just memorize tan is sine over cosine, and the rest are inverses of sine, cosine, and tangent. Ever wonder why angles are always called theta? No one's really sure who started it, but mathematicians everywhere just agreed one day, let's make this Greek. Theta became the go-to angle name, maybe because it sounds mysterious, like a secret society for triangles. Or maybe it just looked cool in chalk. Honestly, the real reason might be this. Alpha and beta were busy with physics. Gamma got recruited by radiation. So theta stepped in and said, "Fine, I'll handle the angles." And we've been rotating around it ever since. Sine and cosecant always share the same sign, because they're reciprocals. But honestly, I wish cosecant were the reciprocal of cosine. That would be easier to remember. Instead, someone in ancient math naming committee decided to confuse generations of students. It's like naming your cat Mr. Dog and saying, "You'll get used to it." Spoiler, we haven't. Oh great, another mnemonic. Cast. Sounds simple, right? Just remember CAST to know which trig function is positive in each quadrant. Except they forgot to tell you one thing. Where to start. Do you begin in quadrant 1 like every other normal math idea? Nope. CAST wants you to start in quadrant 4. Because of course it does. Why not make things just slightly more annoying? So now, instead of just thinking about signs, you also have to remember a random counterclockwise acronym that starts in the bottom right and spells something completely out of order. Thanks, trigonometry. Not only did you make me care about angles, you gave me a logic puzzle just to remember which function is allowed to be positive. Figuring out the quadrant from trig inequalities is like tracking down where 2 undercover spies secretly met. You're told which trig functions are positive or negative. Your job? Search the 4 quadrants and find the one that fits their sign profile. It's classic detective work. Only one quadrant fits both clues. Case closed. Trig Bureau of Investigation wins again. The first step is always figuring out the quadrant, because signs matter. Tangent is y over x. But is it minus 3 over 4, or is it 3 over minus 4? You wouldn't know the correct values of x and y unless you know the quadrant. Start with the detective work. Before you start to panic, I must say, this formula is way out of the scope of this course and you need not worry about it. But I couldn't resist. Because this is often called the most beautiful equation in mathematics, and here's why. It connects 5 of the most fundamental constants in all of math. E, the base of natural growth. I, the imaginary unit. Pi, the circle constant. 1, the multiplicative identity. And 0, the additive identity. These numbers come from completely different areas, growth, geometry, complex numbers, and arithmetic, and yet here they are, in perfect harmony. It's like math's version of a cosmic love letter, exponential growth and circular motion, real and imaginary, all woven into one stunning identity. No wonder Euler's formula is called the Mona Lisa of math. It simply whispers the unity of the universe.